here to, okay, so in progress. Let me fix my screen. So building blocks. Can you guys fully see my screen?
Yes.
Okay, great. So, and then once we have the unit of measure or the unit of the value, then the next thing that comes in mind is transaction, because we need to exchange those value. It goes from one point to the other point. Those are called transactions, the second building block. And next, once we start making those transactions, there's a need for an accounting system. You know, at any time, any point in time, I want to know, what do I owe in terms of how many unit of values do I have? So that's where the wallet comes in. And as I make those transactions with my peers in my community, those transactions are first gathered somewhere, and that's called a transaction pool. And now we need to agree on how we identify which transaction are valid. Because if I say that, oh, I send a bag of, let's say, potatoes to Ted, or I don't know, something, such a thing, I transact with someone, we need to have a way to agree that that transaction actually happened. And that's all about the validation process, which also include a consensus program or algorithm that help us do that. And lastly, once we have those transactions that would grow, we need to find a way to structure them and save them and persist them somewhere. That's when the blocks come in. And remember, I said that I kind of mix up blockchain and DLTs. Blocks are more referring to blockchain, but the idea here is that the general idea is that you need a way to organize those transactions, structure them in such a way that they are easily accessible. So I think we already described that. So I just want to spend a few more time here on the concept of a wallet. Usually a wallet in these systems is characterized by a public key and a private key. The wallet helps you track your balance, your account balance, and your public key is like your, the public tool through which people can find you, or people can reach out to you, or people that want to transact with you, or make transaction with you. The private key is for you to keep and sign those transactions, which will then allow, any person willing to validate the transaction or to confirm that the transaction is truthful, to validate it. So we already talked about that. You need to verify transaction validity. Something that I want to spend a little bit more time here on is we already mentioned the fact that the transactions are validated through a consensus algorithm, and then they are packed together and added to a structure. It could be blocks, it could be any other structure, as we will see in the next slide. But what I want to stress on is that there are several validation strategy or consensus algorithm. There's proof of work, proof of stake, and proof of reputation, proof of authority, proof of meme, and so on. I invite you to do some research on that regard. But just to spend a little bit time on these three that are fundamental. Proof of work is all about putting the trust in the machine and having the machine perform some really resource intensive work or job in such a way that in order to validate, if you want to trick the network, you will have to put together a lot of computers, computing power to be able to trick the network. That's proof of work. So the whole trust is put into the machine, and the process of validating all the algorithm is super resource intensive. Proof of stake stays away from that approach and say, okay, we're going to give a little bit of power to humans. They're going to put their stake, which means they're going to put a warranty in general money, a big chunk of money, in such a way that if there are part of the validation process of transaction and they make false claims, at that point they can lose their stake. So that's the incentive. And now when the transaction are validated, they get some fees, obviously, from those transactions. Proof of reputation is all about reputation. I think this one is really interesting, especially in our context, given that it's what we've used for years in our tontines, in our parents do tontine, and they really care about reputation. Who is the person, the community who is most likely to save the money, or for example, and it's someone who has money. And then who is the person who is supposed to lead other people or that we can trust? Is the person with the best morality, who has proven through his habit, his action, and so on. So we are kind of like we both combine what I would say proof of work and proof of stake to some level. With proof of reputation. Proof of authority is another one, and it's more geared toward medical systems, and we'll get a chance in our future hackathons to talk about it. So we already talked about that. So before we move on to the next thing, let's see. I think that's good. So our next module is, or maybe I want to pause here and make sure that if there are crucial questions, we'll answer them. But tomorrow we'll definitely go through some exercises that will help us clarify this even more. Are there any questions so far? Good. So this module is really about looking into functional and emergent characteristic of distributed ledger technologies. By functional, I mean, what we expect at the functional level, how they work, what do we expect, what are the characteristics that we expect them to have in their functional aspect. By emergent, it's kind of what we get once we have those functionality set up. For functional characteristic, we have decentralized or decentralization, consensus base, we have immutability, distribution, and then we have security. I think these terms on their own are self-explanatory. On the right-hand side, we have, when it comes down to emergent characteristic, once we have all those functional characteristics secured, and then we can have trust computers to some level to do all this work for us. The auditability, we get it for free because we have data that is sitting there that is immutable, so it cannot be easily tampered with. So we get auditability for free. Same for transparency. Anonymity, this one is questionable because some blockchains are really public. Some are permissionless and some are permission. Permission just mean private blockchain, and permissionless just mean zero privacy blockchain. And then the last one is programmability. You've heard a lot about smart contract, which are just like an emergent characteristic, stemming from those functional characteristics we just talked about. So I think we already talked about immutability, the fact that once the data is safe, it cannot be modified or tampered with. We talked about auditability and programmability, so I will skip those. And now we're going to move on to the next module, which is really looking into how DLTs can replace traditional book keeping record methods. What DLTs will do is they will intervene in many aspects. They will for sure remove central authorities if they are used appropriately. They can help us remove single point of failure that we observe in traditional bookkeeping record methods. They can push power to the edge. So the idea of having one central authority who controls everything, who validates everything, that could be spread across, you know, communities, and every single individual within the network can do its part. Real-time data sharing, that is something we don't get with traditional bookkeeping methods. Transparency, consistency, security, trust, and real sense of ownership. This one is really important. So overall, DLT will intervene when it comes down to you know, data collection, data sharing, and the locus of control. Because right now the way we function is that we basically have control in the hand of a central authority, and us user producing all that value, all that information, we don't have very much control over it. So that concludes with that module, and I want to take another quick break here and check if there are questions. I will be happy to answer them. If not, we can proceed. Okay, great. So our next module is really about looking into data structures, the models, the data models that are used to implement all of these greatness, if I can call it that way. Before I get into this, I just want to say that, you know, blockchain is, well, distributed ledger technologies is still in its early days, and there's a lot of potential here. So we basically have three fundamental, three more common data structures, which are blockchain, which basically translate into a link list of block. We have directed acyclic graphs, with, you know, send us back to the concept of graph in mathematics that are awesome. They've been used in many scientific fields, whether that's biology and many other, artificial intelligence, and so on. And lastly, we have hypergraph, which is kind of like the generalization of the concept of graph. So let's dive deep a little bit into this. So blockchain is basically a link list where elements are blocks. So blocks are blocks are made up of transactions. We already saw that, or we can call data. And they also hold within them, you know, the pointer to other blocks in the list, aka the chain. That's where the word chain comes from. You know, each node in the blockchain, each block or node consists of two fields, as we said, and we can talk a lot about the shortcoming of this structure here, because what's really interesting here in this module is to talk about the blocks, the different structure, but also compare and contrast. And actually, might be better to do this at the end after we present this all these structures. So the next one is what we call DAG, which stands for a directed acyclic graph. And as you can see in the picture, that's a structure. So we basically have, you know, vertices and edges. Edges are these little lines that you see, those arrows, and vertices are those little squares. Those vertices represent transactions, and those lines represent, you know, if a transaction going from one point to another, you know, the squared not don't only represent the transaction, but they also carry informations about like who is transacting and who is the transaction being sent to, and so on. So I think that's it for the graph. Or what I want to add here is that this structure is based, DAGs are definitely they come from mathematics, the concept of graphs in mathematics, basically. And just one last specific thing here is that, as you can see, each um, uh, edge it is directed from one vertex to another. And again, edge here is that arrow, and vertex or vertices are, those little squares. And the other particularity is that the fact that it's directed, you cannot have a closed loop. So you can go from one path here and find a way to come back to that same element you started from, or that vertex you started from. So lastly, we have hypergraphs. As I said, they are the generalization of um, the concept of graphs. And hypergraphs are different in the sense that, if you look at this top image up here, or the bottom one, you should pick your one. But let's do the top one. I think it's more explicit. On the left hand side, the A figure here, you see that we have vertices, those little rounds, and then you can see these edges going from one vertex to the other one, and so on. But that's really interesting when we look at the hypergraph, which is definitely different. So when we're talking about graph, one edge can only connect two vertices. When we talk about hypergraph, one edge, so the concept of edge, which was here a line, becomes kind of a circle. And at that point, it can connect multiple vertices. As you can see, we have edge 2, which connects V5, vertex 5, vertex 3, and vertex 4, and so on. So that's the concept of a hypergraph. And this structure gave us something really powerful that we can use to, model the flow of data, or how we structure and organize data within a distributed ledger technology implementation. So let's dive into this image. I don't necessarily expect you to fully understand this at this point, but at least I wanted to share this with you because it's something that is really, I think, key to the reality of the local context we have here. And so down here, this is a picture from the Constellation distributed ledger technology, or blockchain, if I don't know if I should call it blockchain, but they call DAG Constellation. So obviously their structure is based on graphs, and specifically in hypergraphs. So what I really like about it is you can think of them as a blockchain of blockchains. So there's no one all-encompassing blockchain as it happens with Bitcoin and with many Ethereum. And I know now they're trying to do some solutions where they talk about state channels. Same for Cardano, but I think it's something that must be integrated into the blockchain, and just understand that the blockchain should mimic the way we organize naturally by creating these little like aggregates that have affinity, community, or aggregate that have a certain level of affinity. They can create their own reality within the network and validate their transaction. And now those little groups, as you can see down here, state channel 1, state channel 2, and so on, they can then come together at a higher level, at a hierarchical level, and create now other aggregation, and so on and so on. And that brings us to the higher level up here, which is what we'll call a blockchain. So a blockchain becomes just something that is there to capture all the information that was validated at a very, very low level and percolated up to the to it. We'll come back to this concept. So I just wanted to share that to kind of incite your curiosity in this blockchain. The next one is really a case study because, when we talk about this concept, they might sound abstract and very, very far away from our reality. So we wanted to make sure that we presented one specific example that we are working on right now in such a way that that can spark some degree of inspiration. So we blockchain incorporate what we call non-fungible token. A token, as we will see, is just something that can help you represent a concept or something happening or not happening, but it can help you represent any situation. A non-fungible token, that's what they are. Its non-fungibility characteristic just means they are unique. So even if you have two things of the same physical aspect, emotionally, at information level, and many other aspects, they're not the same. The coin your grandmother that you only saw one time in life gave you is more significant to your eyes than any other coins you might just find out there. So now let's move on to how we can use this technology to solve like specific problems. So first of all, non-fungible tokens. As we said, it's a thing that serves as an invisible or tangible representation of some sort of a fact, a quality, a feeling, etc. So they are obviously unique because we can use cryptographic, aspect of the blockchain to make them unique. They are kind of like digital watermark. And in that picture there, what you're seeing is the cover of a documentary that was, produced in WADA. And the documentary was kind of showcasing what WADA is all about, how they started. We worked with Petra, and that picture there is showing the setup of our interns in our hub. And these NFTs, non-fungible covers, movie covers, are kind of mimicking the fact that when you go in a movie store and you buy a DVD or whatever, you can have like covers on the DVD that are totally different images, personalized images. So this is what people that got this movie were able to get as a non-fungible token. So they are unique. Even if two people get the same image, they are still unique to some degree to them. So that's one specific example. Here, the second one is really about how can non-fungible token be used in the agricultural or farming field, which is what we are working on right now. So it started with the problem of realizing that rare and symbolic tree species are overexploited everywhere in Africa, and specifically more specifically in the east region of Cameroon. And to date, there's no effective program that exists to, curtail that trend or fix that problem. So what we did is we thought about a solution that consisted of planting trees, or those rare species trees, but turning them into dynamic NF trees. And in that process, we can create awareness, we can facilitate their protection, and then we can facilitate their tracking and their extension. And most importantly, we can create a whole economy around it. So in a more practical way, people will be able to own an NFT on our farm, and that NFT will be connected to a specific tree that there can be a form about, how it's being treated, and they can even like initiate actions go and take care of my tree. I want to pay one specific local worker within your farm that would take care of my tree all year long. I want you to, create an art project with my tree leaves and send it to me. I want to come and visit my tree. And even more importantly, a virtual reality where those owning trees can navigate within the farm and have like the sensation that they are living with their tree spirit. And the last aspect of this that I don't want to unveil it right now, but it's about like creating a real economy and making sure that we also add a little bit of touch of the invisible aspect of things, and how we can connect to a tree, to its energy. That we will develop on that later. So that was the first case study. It's reality here in our Cameroonian context. And I want to stop a moment and check if there are questions. Are there any questions? No. So let's move forward. I just want to make sure that I'm keeping track of the time. Okay. So the next thing is really,
Please, I have
yes.
a question.
Yes, go
I have
ahead.
two questions. The first question, if you can note it there, please. The first question is, did the DLT based on the decentralized or distributed network? And the second question is, where is because you have talked about NFTs, where are those NFTs stored? Is it in the blockchain or in another place? If you can bring precision there.
Yeah, sure. Was that Ted asking the question?
Yes.
Okay. So your first question is the DLT that the eventual DLT that we'll build, is it based on the principle of a decentralized network system or a distributed network system? Is that right?
Yes.
Yeah. So we won't be building a distributed ledger technology platform here. We will be leveraging Cardano and any other distributed ledger technology platform that is already built. And the NFTs that we will create will live within those platforms. And those who acquire those NFTs or NF3s will have access to them in their wallet, because an NFT is just a token, just like ADA that you have in your wallet. So they will just have that present in their wallet. So they can send to someone, they can do whatever they want with it. Does that make sense?
Yes. Okay, thanks.
Sure. Okay, so I see Maureen, is everything okay so far? No questions? Memos, do you have any question?
I'm good.
Great. So let's move forward. So again, our second case study is really thinking about the healthcare system and how this technology can bring us so much relief. So let's dive into it. So there are several problems in the healthcare system today. Just let's run through them. So there's the question of identity. So we don't know who is who. We don't know which medicine is what, where it's coming from. So we can they flood the market. So the notion of identity here is related to identifying any players, whether that's human beings, whether that's a device, whether that's a drug, a medicine, there's a need to identify them and track the process of making them, which leads us into the health supply chain management. So, all these tools, all these medicines, all these, little devices that are used in medicine, in healthcare, we need to have a way to track them, the way they are made, how they are transported to their final destination. Some of these are very sensitive to temperature variation and so on. So the next one, the third point, is patient record management. And this one is huge in our context. And I say this thinking about myself. Just recently, I was in Douala going for some medical checkup. I forgot. You will be really familiar with this top left image here, where you have several what we call carnet de santé, which is little booklets that you go to the hospital or health institution with, and they make kind of their report in it. So a lot of people have that as their medical record. As you can see, easy to lose, easy to be destroyed, easy to I don't know. So many things. And then so there's a need to really think about how we manage our patient record. Health institution information system. So, health institution do exchange information with many other institutions, whether that's the government or, the public and so on. And there need to be a way for people to have access, or other institutions to have access to that. Health insurance and health claim. When you are sick and you have an insurance, and very often in our context, process for making claims is very tedious, slow, and it never ends, which is at the expense of the patient. So that's a problem that healthcare can solve by making all this data easily accessible to all the parties. Compliance is another big one. You want to make sure that healthcare is a very sensitive, domain, where there are a lot of governmental laws and all of that needs to be respected and followed. The last one is artificial intelligence. Just thinking in terms of patterns that shows themselves when you have this massive amount of data that you're sitting on, that we just went through. That's a lot of data that we can potentially generate. Artificial intelligence here can really give us a hand in figuring out patterns, so we can use it to help us figure out patterns in such a way that we can anticipate our decision. So those are some problems. So the absence of those specific aspect in our healthcare system, I think just make it so brittle and insecure and unsafe at the same time for our communities. So now, what's the solution? The solution is really simple. It's really about thinking at the center about a blockchain, which will act as an infrastructure through which we can plug some of the very fundamental things, such as a smart contract layer, an identity management and membership service layer, API for developers to, just express their creativity by talking to those other layers that we just talked about. Interoperability layer is the component that will help us, be realistic on the fact that if we build the system, other people might want to build other systems. So we need to have a protocol to communicate in between systems. Blockchain as a service, again, we want to make sure that we understand that there are communities that have some level of affinity. They come together and they set up their own a way of functioning and validating their transactions. So that will serve for that. And policy management, again, this is a sensitive area, and the government needs to come in and regulate it. That layer can help for that. And you see, on top of that core piece, we then have interfaces for different players: the health insurance, the insurance claim, compliance authority, hospital information system, patient health record, traceability, traceability and supply chain, which directly talk to warehouses, logistic, distribution, pharmacy, and so on. So that's the dream system that we can build to really bring a solution to this chronic problem in our healthcare system. The most important of all being like the patient record management, and then how we can leverage those records to see patterns and anticipate some decision, working hand in hand with artificial intelligence, and also making sure that in that process that we identify all the players in the system and in a unique way, in such a way that we know who we are dealing with. So that picture is getting just more into details. These are some specific examples. I just run through them. Oh, I see a hand there. Memos, if you can allow me just to conclude, and we'll get to the one. I will take 1 or 2 questions before we take a break. Yeah. So these are just like some specific examples: Patientery platform, Chronicle platform, PharmaTrust, that are doing some great work. Patientery is really about like working on the health record maintenance for users and giving control to users and allowing them to selectively share their record with third parties. Chronicle is really about making tools that allowed administrations to build solutions on top of their network to facilitate trust and just enable some level of automation between all the trading partners involved. PharmaTrust, lastly, is here to help protect patients by eliminating counterfeit products, working specifically on the area of supply chain management and making sure that that process is traceability, and the supply chain management aspect of tools and drugs is being like observed or met to some degree. So future, again, here we need to think about a new paradigm when it comes down to distributed ledger technology. We need to think about models that mimic nature, and by this, the general term is biomimicry. We need to really focus, and I'm calling on my young brothers, think about an African-centered blockchain. Because very often I hear people presenting blockchain and talking about, oh, in this context, there's no internet, in this context, there's no electricity, and so on. Yes, we need to deal with that. That's the reality of our context, and we need to build systems that are reliable, resilient, and that take into consideration all those aspects. So just in terms of like the new paradigm, we need to really focus on the scarcity and fear factors that we see in many distributed ledger technologies today. Oh, it's small. If you're not there now, if you don't grab it now, you won't have anything. So that creates fear, which is the same with money. We need to think about the spatial asymmetry and temporal asymmetry that we observe in pretty much all of the blockchains. That being that for those who are born now and are able to acquire some data, they have more chance than those who will be born tomorrow. So we need to really, I think we already talked about that. And we need to focus, obviously, on testing model that nature has shown us, has functioned with over billions and billions of years. We need to focus on fractals, atomic models, again, clues from how things organize in nature must be our friend. And how about we get inspired by what Monnaie Libre has done in France, Stéphane Lagarde. How about we get inspired by what Cardano is doing, through which we are here. We are here today. And how about Holochain and Constellation DAC? Those are just some pointers that I wanted to share with you as inspiration path or research path for us. And lastly, I think that ultimately the solution to what we are looking for will come from, that circle, which is the circle of everything. Thank you for our dear listeners, and that's the end.